my name is Nurul Assyikin binti Yusree. So, what are heavy metals? Heavy metals are elements with a density greater than 5 grams per cubic centimeter, often toxic to living organisms even at low concentration. As example, zinc, lead, and mercury. Did you guys know our planet is about 71% covered in water? Heavy metal pollution in seawater. In marine environment, heavy metals are naturally occurring substance often present in minimal amount. In many of these natural water systems, the concentration of metal ions have unavoidable growth due to human activities. The heavy metal that should worry aquatic system the most including lead, copper, zinc, cadmium and mercury. Many of these metals like copper and zinc are necessary for metabolism at lower amount, but over certain limits, they are poisonous to life. Cadmium and lead have no biological purpose. Aluminium, chromium, silver, arsenic and antimony are other components of concern that have led to significant issues in marine environment. Toxic compounds that accumulate over time tend to concentrate more and more in one particular tissue. Toxic chemicals can build up and cause concentration in animals at higher trophic level to be amplified in the food chain. So, can you think where the heavy metal come from? First is industrial activities. Mining, smelting, manufacturing, and fossil fuel burning release heavy metal like lead, mercury, and arsenic into the environment, eventually finding their way into waterways. Next, agricultural practice. The use of pesticide and fertilizer as well as livestock waste runoff contribute to heavy metal contamination in river and coastal area. Next, urban runoff. Paved surface in city collection pollutant like car exhaust and tire wear, which are then washed into waterways during rain event. Finally, water waste discharge. Untreated or improperly treated waterways can contain high level of heavy metal, contaminating aquatic ecosystem. So now, what are the impacts of heavy metal pollution? Okay, first, toxicity. Heavy metals are harmful to marine life even at low concentration. They can disrupt physiological process, reproduction, and ultimately lead to death. Next, bioaccumulation. These metals tend to accumulate in the tissue of organisms and become more concentrated as they move up the food chain. This phenomena pose a significant threat to a pet predator and human who consume seafood. Next, disruption of ecosystem. The harmful effect of heavy metal can disrupt entire ecosystem, affecting food web, biodiversity, and ecosystem service. And finally, human health. Consumption of seafood contaminated with heavy metal can lead to various health problems, including neurological disorder, development delays, and cancer.
Assalamualaikum. My name is ABDULLAH bin Muhammad NASSER. I will proceed about the data of the heavy metal at the seawater. Figure 1 display the measurement of various essential water quality parameters obtained through multi-probe meters at 8 different sampling locations, depending on when the data was collected. Surface water temperature ranged from 30.5 degrees Celsius to 31 degrees Celsius. The dissolved oxygen DO values in this investigation varied from 5.2 to 9.1 mg per liter, with station P2 having the highest level and station P5 having the lowest one. The sample total dissolved solid TDS and turbidity range from 31.1 to 32.9 mg per liter and 5.9 to 22.2 NTU respectively, with position PC showing the highest value. Furthermore, pH reading varied from 8 to 8.3, indicating a relationship with salt concentration between 31 and 33.1 mg per liter. Then, we will continue about the concentration of heavy metal in seawater. Figure 2 provides information on the total metal concentration in seawater collected from the coastal area of Kuala Langat. The data is presented as mean value with standard deviation, and the results are expressed in micrograms per liter for both heavy metal and radionuclide. The concentration of dissolved heavy metals such as lead are 0.36 to 5.33 microgram per liter. For the copper, 75.2 to 621.5 microgram per liter. For the zinc, 11.92 to 30.5. For uranium, 4 microgram per liter to 4.65 microgram per liter. Next, we will continue about the heavy metal in fish tissues. Figure 3 represents the findings on the concentration of heavy metal in fish tissues obtained from the coastal area of Pulau Indah. The metal concentration display considerable variability across different fish species. Lead and copper concentrations were the highest in Jonius belangeri and Parastomatius niger, measuring 1.45 plus 0.02 and 2.5 plus 0.1 mg per kilogram respectively. The highest quantities of uranium and zinc were found in Aries maculatus and Jonius belangeri with value of 1.9 plus 0.05 mg per kilogram and 25.95.0.08 mg per kilogram respectively. We will now continue about the transfer factor. Figure 4 shows the heavy metal transfer factor in fish tissues that were taken from the water. One of the most important aspects of human exposure to metal in the food chain is transfer factor value. Because of its conceptual and mathematical simplicity, the transfer factor is frequently selected as the transfer parameter for dose and risk calculation. According to the result, zinc followed by lead followed by uranium followed by copper was the ranking order trend for transfer factor of the heavy metal in the 4 fish species. In every sample, zinc had the greatest transfer factor values of all the chosen heavy metal that were estimated. Because the transfer factor value are less than 1, there is just transfer of lead, copper and uranium rather than build-up in the fish tissues. Now, we will look at the safe rate of intake. It is crucial to understand that the amount of heavy metal detected in fish sample from the coastal area and Pulau Indah estuaries are safe for ingestion by human. Thus, in the current study, the safe levels of the heavy metal under investigation were determined using the provisional tolerance weekly intake and provisional tolerance daily intake values as reference value. The result of the current study estimated daily intake and estimated weekly intake for an adult weighing 70 kg as average, as shown in the figure. These figures were calculated using the assumption that an adult will eat 15.8 grams of fish per day or 110.6 grams per week. This figure also shows that estimated EWI and EDI value for lead, copper and zinc in the current investigation are significantly lower than PTWI and PTDI as stated by Mak Yunus.
Our seawater environment is a valuable resource that must be protected since we rely greatly on it. We have to figure out a solution to the challenges that cause contamination in our seawater environment, particularly heavy metal pollution. There are several solutions that I would like to recommend about industrial, waste concern, agricultural practices, infrastructure and urbanization, where these 3 problems have a great harmful influence on our marine environment. Solution for industrial waste problem. In the face of escalating heavy metal pollution in our ocean due to industrial waste, we must adopt a multifaceted approach to address this pressing environmental issue. Modern water treatment technologies, including electroagglation, ion exchange and membrane filtration, offer effective means of removing heavy metal from seawater. These cutting-edge processes have demonstrated success in various investigations, providing a realistic strategy to combat contamination. Additionally, embracing natural solutions like phytoremediation, where certain aquatic plants act as hyperaccumulators to absorb and concentrate heavy metals, present an environmentally friendly and cost-effective alternative. By deploying this plan in artificial wetland or on floating platform in affected areas, we can make significant strides in reducing heavy metal levels. Next, equally crucial are stringent environmental regulation and enforcement procedure to prevent and control industrial waste discharge into seawater. Implementing policies that promote cleaner manufacturing technologies, waste reduction and recycling can limit the release of heavy metal. Constant monitoring and imposing harsh penalties for non-compliance will ensure industries adhere to environmental regulation, fostering a more sustainable and responsible industrial landscape. In combining innovative technologies, natural processes, and regulatory measures, we pave the way for a comprehensive and effective solution to the critical challenge of heavy metal contamination in our seawater. Next, solution for practices in agriculture. In the battle against heavy metal pollution in our sea, stemming for agriculture activities, a holistic approach is essential. Embracing sustainable farming practices, precision agriculture emerges as a powerful ally, utilizing technologies like GPS-guided equipment to optimize fertilizer and pesticide application. This not only enhances nutrient use efficiency but also minimizes runoff, mitigating the risk of heavy metal entering our water bodies. Next is agroforestry system.
Agroforestry is a sustainable land management system that integrates the cultivation of trees and shrubs with crops and/or livestock. It combines traditional agricultural practices with forestry to create a more diverse, productive, and resilient system. In recent years, there has been a growing emphasis on innovative agroforestry ideas to address contemporary challenges such as climate change, biodiversity loss, and food security.
However, our efforts must extend beyond techniques to strict enforcement and law and best management practices, ensuring responsible disposals of pesticide container, erosion management with cover crops, and constant monitoring of water quality in agricultural runoff. Regulatory framework that incentive sustainable farming practice and penalize non-compliance are paramount for fostering a responsible approach to agriculture in coastal region. In the integration of precision agriculture, agroforestry, and robust regulation, we forge a formidable defense against heavy metal pollution, safeguarding the health of our marine ecosystem for generations to come. Last but not least, solution for infrastructure and urbanization problem. As we confront this challenge of heavy metal pollution in our seawater stemming from urbanization and infrastructure, a multifaceted strategy is imperative. Integrating green space into urban design act as a natural defense, curbing runoff and enabling vegetation and soil to effectively absorb heavy metal. Green infrastructure from rooftop to permeable pavement and urban wetland become a vital ally, capturing and filtering runoff to prevent pollutant from reaching our water bodies. Next is about sustainable construction technique.
A sustainable building is one that looks to reduce the impact it leaves on the environment through its total life cycle. After construction and use, it looks at the whole life of the building, including its demolition or deconstruction. A sustainable building also looks to use resources to build it that have low embodied energy. They have been sustainably sourced and can be used in another way or recycled at the end of their useful life as part of that building.
Lastly, the linchpin of our effort lies in the development and enforcement of stringent environmental legislation coupled with robust public awareness initiatives. By minimizing industrial discharge, construction site runoff, and improper waste disposal, we can significantly enhance seawater quality. Public engagement and education programs are instrumental in fostering a collective sense of responsibility, encouraging sustainable practices, and reducing the introduction of heavy metals in our urban water cycle. In this comprehensive approach, embracing green infrastructure, sustainable construction, and strict legislation, we forge a resilient defense against the encroachment of heavy metal pollution in our coastal water.
How much does the general population know about the contamination caused by heavy metals in the sea? True, stakeholders, notably fishermen and implementers, are aware of the reason why seawater is contaminated with heavy metal, but they still find it difficult to convey or explain it to the others. This is explained by the respondents' claim that they learn about the heavy metal contamination in bodies of water from news broadcasts on television or radio. Additionally, it was shown that although implementers have a high degree of awareness with categorical mean 3.38 regarding the source of heavy metal contamination, fishermen have a moderate level of awareness with categorical mean 2.74 as tested by Javier. Thus, it is necessary to launch a campaign to raise awareness of heavy metal pollution in the water. The purpose of this is to raise community awareness of the potential negative effect of continuing heavy metal contamination if quick action is not taken. This campaign seeks to educate the public on the root cause of pollution, as well as the most effective ways to address this issue. Social media has emerged as the most effective medium for disseminating information in this age of globalization. Undoubtedly, every person has a personal electronic device. Social media sites like Facebook, Threads, Instagram, and TikTok are essential apps for all societal level. This program aims to engage all of the society levels so that the children have early exposure and the elderly can take initiative and serve as a role model for the younger generation. In relation to heavy metal contamination, we will distribute poster and short videos. More of like, comment, and share receive indicate how much of an impact this campaign is having on the community. Furthermore, a game was designed with society effects in mind, a werewolf themed game about heavy metal pollution, in order to eliminate other players. The game substitutes heavy metal contamination, that is, the poisoning of an environment like the seawater, coastal area, and estuaries, with uranium, zinc, and copper. There are also members of the higher authorities, such as Jabatan Perikanan Perlis, Marine Protected Areas, and Worldwide Foundation to replace the character of the hunter. The purpose of this game is to make everyone aware of the consequence that will arise from heavy metal contamination if the environment is not preserved. The effectiveness of the game can be measured by giving the player a Google form for feedback. That's all.